Hello guys, it's Rina again from Zero in Cipher. I haven't posted any tutorials for a long time and I'm really sorry for that. I promise I'll try to be more often with my videos. So in today's tutorial, I'm going to show you how to create a magic square in Z. I have divided this tutorial in two parts. In the first part, I will try to explain what is a magic square and how to make it, and how we are going to develop a magic square using code. And then in the second part, I will be implementing the program in DevC. So without any more delay, let's get started. What you can see here is a magic square. It's as you can see, it's a 3x3 square or matrix or table, whatever you want to say it, and it has 3 rows and 3 columns and contains a bunch of numbers. So what is the magical about this square? It contains a bunch of numbers in a certain arrangement so that the sum of the numbers of each row, column and main diagonal are same. For this magic square, each row and column and diagonal add up to 50. So, a magic square is an n by n matrix in which every row, column and diagonal add up to the same number, which is called the magic sum. For this magic square, the magic sum is 50. So, here are some facts about magic square. If the row or column number is n, then the elements of the square will be 1 to n square. So for this magic square, our n is equal to 3 as it's a 3x3 magic square. So our elements will be 1, 2, 3 square, that is 9. So you can see here the number of the magic square will be 1 to 9. And each number occurs exactly once. Now I guess it's clear to you what is a magic square. And now I'm going to show you how to make it. There are so many ways to make a magic square. I'm just showing one of them here. This way can only be applicable when the value of n is an odd number. That means you can make a 3x3 or a 5x5 or a 9x9 magic square in this way. These are the main rules for making a magic square. We have to repeat the rule number 3, 2, 3 and 4 a couple of times. During this procedure, some conditions can occur. So let's just start to implement this 3x3 magic square and we'll see the conditions during the implementation. So at first we need to place the first number in the first row's middle square. So this is our first row and this one is the middle square. So we are putting our first number here, that is 1. And then we need to go one step right. So we are taking one step right, then one step up. And now we are leaving the top. So here comes the first condition. If we are going one step up from the first row, we'll end up on the last row and the column will remain the same. So we are going one step up from the first row and we'll end up here on the last row and the column is remaining the same. So this is the place we are going to put our next number, that is 2, and again go one step right and we are leaving the column here. So this comes the second condition. If we are going one step right from the last column, we'll end up on the first column and the row will remain the same. So we are going one step right from the last column, we are going to wrap to the first column and the row is remaining the same. So this is the place, and then we are going one step up. We took one step right and then we're taking one step up. So this is the place we're going to put our third number, that is 3, and then again one step right, one step up, and this place is already taken. So here comes the third condition. If the position is already filled or taken, then we will reverse to the original position and go one step down from there. So we'll reverse to the original position and going one step down from there. So we'll put the next number here, 4. So again, one step right, one step up. Our next number 5, one step right, one step up. Our next number 6, one step right, and we're leaving the column, so we'll end up with the first column. And then one step up, we're leaving the top, so we'll end up with the last row, of course. So this place is taken already again, and so we'll reverse to the original position and take one step down from there. So this was our original position, and we are taking one step down from there and putting our next number, that is 7. Again, one step right, one step up, and 8, one step right, one step up, and 9. So practice it a couple of times, and it's a very easy way to make a magic square. Now we will show how to implement this magic square using code. For making a magic square, at first we need to create a matrix. So this is the matrix named magic, and I've created it with 3 rows and 3 columns. So here is the 3 row and here is the 3 column. So you guys can notice that our third row or third column is showing number 2 here. It's because most programming languages start indexing with 0, and C programming also do the same. So as it's our first column is indicating 0, our second column is 1, and our third column is 2. So remember that our last column number or last row number is always less than the main size number of the matrix. So we need to create another variable named size. So our matrix here, the matrix size is 3, and now we want to show our program the place we're going to start. So we know that we need to start from the first row's mid column. Our first row number is always 0, but our mid column will vary from matrix to matrix. So for it will be different when the matrix size is 5 by 5 or 9 by 9 or 11 by 11. The mid column will always be different. That's why I need to create another variable to indicating the mid column of the matrix. This is the start variable. It is going to indicate the starting column. So it says size by 2. So for these matrix, our size is 3. So 3 by 2 is equal to 1.5. As our start variable is integer type variable, so it's just going to ignore the fraction part and will took the integer part. So our start column will be 1 here. Now we have our starting row number and our starting column number. So this is the place where we are going to start placing our number. So here we are just placing 1 in the first row's mid column here, and here is 1 in the first row's mid column. Now we have placed first number here, so now we need to know the final number we are going to place in this magic square. So our final number is equal to size square. For this magic square, and our final number is equal to 3 squared, that is 9. So we're just going to put 1 to 9 numbers in these squares. To develop the code further, we're going to need some more variables. So first variable here is integer num. Num variable will indicate the current number that we are going to place in the square, and our current row is indicating the current row number we are working, and our current column variable is indicating the current column number we are going to work, and the next row and next column number is going to indicate the next row number and next column number in the matrix. Now, if you guys can remember, after putting the first number, we needed to repeat row number 2, 3, and 4 a couple of times, as we need to repeat some same procedures. We are going to put those procedures in a for loop. So this is the for loop. From here to the first semicolon is our initializing part, and this part is our condition part, and this is our increment part. As we already placed number 1 in the first part, now we are going to start with number 2. So our num variable is now initialized with 2, and we are going to placing our number from this square. So our current row will be 0, we will start from 0, and our current column will start from the start variable, that is 1. So we are going to start placing our number from this square. Then our condition part, it says our num variable is less than, is equal to, or equal to our final num variable. So that means our for loop will be continuing till our num variable is less than or equal our final num variable. So for this matrix, our num variable is now 2, as we have initialized with 2, and our final num, we have saw that our final num is 9. So yes, the condition is true. Now our program is going to enter in the for loop, and after placing number 1, we need to go one step right. So when we are going to take one step right, we need to check some conditions, as we have seen earlier. One line code for taking one step right from one column to another. It says next column is equal to current column plus 1. Suppose our current column number is 1, and if we want to take one step right from there, our next column number is going to be 2. So if we simply add 1 with our current column number, we can easily get our next column number. This was pretty simple. And now this code is for checking the condition if our column is going to leave the site or not. As we are going to check a condition, we need to start if statement here, and this is the condition part. It says current column number plus 1 must be greater than size minus 1. Current column plus 1 is the next column number, of course, and size minus 1. If you guys can remember, I have already told that our last column number or last row number is always 1 less than the size number of our matrix. So size minus 1 just indicating our last column number here. So when we are going to take one step right from the current column number, if that is bigger than the last column number, then we will assign our next column to 0. For example, if our current column number is 2, then 2 plus 1 equals to 3, and our size of the matrix is 3, then 3 minus 1 equals to 2. So the condition becomes true here. So we will assign 0 to our next column variable. That means we are taking one step right from here, then our next column is going to be 0, so that means our next column is going to be here. If this condition gets true, our program is going to execute this code, and otherwise our program is going to execute this code. So we just insert this code in the else section. Now let's see for these metrics how these codes are going to work. So we have already put 1 in our first position. So now our current column number is start. That means we have seen that start is 1. So 1 plus 1 equals to 2. And then our size minus 1, size is 3, then size minus 1, 3 minus 1 equals to 2. The condition is not true here. We're just going to jump on the else part. So our current column is 1, and just add 1 with that. 1 plus 1 equals to 2. So our next column will be 2. After taking one step right, our current position is here. Now according to the main rule, we need to take one step up from here. This is the code for taking one step up from one row to another. It says next row is equal to current row minus 1. That means to get to the next row, we just need to decrement our current row by 1. Suppose our current row number is 2. If we take one step up, our next row number is 1. So if we just simply subtract 1 from our current row, we get our next row easily. And this is the code for checking the condition if the row is leaving the top or not. As we are checking a condition here, we need to start if statement here. So the condition is current row minus 1 must be less than 0. Why must be less than 0? 0 is the very top row of our matrix. So when we are decrementing our current row by 1, that means we are taking one step up from our current row. If that is less than 0, that means our row is leaving the top. That means the condition is true, and then this code is going to be executed. So if this condition gets true, our next row will be size minus 1. And size minus 1 is the last row here. So our next row will be the last row number. So if our row is leaving the top, this code is going to be executed. Otherwise, this code is going to be executed. That's why we just put that code in else section. So let's see just this code, how this code is going to work for these metrics now. Now our current row is 0. 0 minus 1 is equal to minus 1. So the condition is true here. As our condition gets true, our program is going to execute this code now. Size minus 1, our next row is equal to size minus 1. Size equals 3. For this matrix, our size is 3. 3 minus 1 equals to 2. So our next row will be this row. So our position is going to jump from here to here. After calculating the next position where we are going to put our next number, we just need to check that if that place is empty or not. This is the code for checking the condition. So if the position's value is 0, that means the place is empty, and if the position's value is greater than 0, that means that the place has already been occupied. So here we will see if the position's value is greater than 0. That means if the position is not empty, then what are we going to do? Suppose this place has already been taken with number 3. So you guys know if the position has already been taken, then we just need to go back to the original position and go to one step down from there, and then that position will be our next position to put our next number. So this is the code that will do the procedure. It says next row is equal to current row plus 1, and next column is equal to current column. So we will remain the current column and increase our current row number by 1 to get our next position. So for this scenario, our current row number is 0. That means our next row number will be 1, and our current column will be the same. Our next column will be the same as our current column. So our current column number is now 1. So our next position will be 1, 1. That means this square. So we will put our next number here if this place is occupied. Now imagine this scenario. We have put our number 6 in this place, and we need to find the next position for placing number 7. So according to the rule, we just need to go one step right and one step up to find our next position, and then we just find out that the position has already been taken. So according to this rule, we just need to go one row below from our original position, but going one row below from our original position leaves the bottom. So this is the code for handling that situation. So if our row going to row below leaves bottom, then this code will execute it. So when we are going one row below from our current row, we just simply increasing our current row number by 1. So here it says increasing current number by 1 gets bigger than size minus 1. That means the last row number. We will set the next row to 0. That means our first row. Then our next row will be the first row. So basically we are going out from the last row, then we will get enter from the first row. So for this scenario, our current row number is 2, and we're just adding 1 with that to go to our next row. That is 3. Our next row number will be 3 if we go one row below, and our size minus 1 is of course 2. That is our last row number, and this condition gets true. Here that means of course 3 is bigger than 2. That means going to one row below leaves the bottom. So if as this condition gets true, we just set our next row to number 0. That means we will just set our next row to the first row number. So then this position will be our next position to put our next number. For this, our next number is 7. If this condition gets true, this code will be executed, otherwise this code will be executed. So we'll just put this code into our else section. So for this or this scenario where this place is empty and we can put our number easily here, none of this code will be executed. Now, as we have checked all the conditions and calculated our next situation, we just need to put our next number here. So this is the code for putting the number. We'll just set our current row number to next row number, that is 2, a current column number to next column number, that is also 2, and then we'll just put our number to that position. That is, our next number is here 2. We have put already 1, so our number is 2. So we have placed our number 2 in this square. Now I guess you guys are clear about the logic behind the code, and now I'll just show you the code by developing that in dev C++. So let's just jump into that. First we need to include our header first. So include first we need to create a matrix. Matrix that has what? We should create a 99 row and 99 column matrix square. created a 3x3 magic square earlier. So 816357492. So 816357492. Yeah, that's right. Our program is printing the exactly right magic square here. So you can modify this magic square according to your requirements. You can see the procedures by putting some primitive here and there, and you will have the magic square with its procedures. So that's all. So if you guys like my video, then give a thumbs up and subscribe to my channel for more videos. Take care.